Hello everyone. So welcome to today's class. Today we are going to discuss the remaining part of COA. Alright everyone. So let's start. In direct mapping, hit latency equals to hit latency at tag comparator. Okay, and in set associative mapping, hit latency is hit latency of tag plus latency of mux. Okay, in direct mapping, first is number of comparator is 1, second is size of comparator equals to number of bits in tag. Alright everyone. Now let's see set associative. So the very first is number of comparator equals to n way set associative. Second is size of comparator equals to number of bits in tag. Third is tag bits in n way is equals to tag bits in direct mapping plus log 2n associative. Okay, so this is for set associative. Now let's see local miss rate, which is number of misses in cache by number of misses by access to that cache. After that, global miss rate is equals to number of misses in the cache by total number of CPU generated references. Alright. Now let's see access time. Access time in multi-level cache. Access time in multi-level cache, which is level 1. So average time is ht1 plus 1 minus htm plus t1, or t average is equals to t1 plus 1 minus htm. Okay, so this is for level 1. Now let's see for level 2. Level 2, t average, which is h1 t1 plus 1 minus h1 h2 t2 plus t1 plus 1 minus h1 tm t2 plus t1. Okay, or t average is equals to t1 plus 1 minus h1 t2 plus 1 minus h2 tm. Now what is write through? So the word operation time tw is max of Okay, so let's see now the formulas of write through. T average of read HR TC plus 1 minus HR plus TM plus TC, which is, so this HR is read hit, this TC is read data. Okay, after that this is read miss, after that this is read allocate, and then this is read data from cache memory. Okay, T average write, which is H W TW plus 1 minus HW plus TM plus TW. This is write hit, this is word updation, this is write miss, this is write allocate, this is word updation. Okay. So simultaneous access is T average read is equals to HR TC plus 1 minus HR TM. Okay. Now let's see write back updating technique. So T average read HRTC plus 1 minus HR. So percent of data modified okay, which is Tx plus Tm plus Tc plus percent of clean bit. Okay, so Tm plus Tc like this. After that, T average right, which is Tw Tc plus 1 minus again here data modified Ty plus Tm plus Tc plus percent of clean bit Tm plus Tc. Alright. So T average is Wv, which is Fr into T average read plus Fw into T average write. So this is of percent of read operation. This is of frequency percent write operation. Okay. Now we will look into rotational latency. Okay, so let's see now rotational latency. Amount of time taken to rotate the track when the read write head comes to exact positions. So rotational latency is equals to 1 by 2 rotational time. Alright. After that we will see disk access time. Disk access time is St plus rotational latency plus dtt plus overhead. Okay, and overhead also if there is any. And dtt is what? Disk transfer time. Seek time. Okay. Now let's see cylinder number. Which is equals to given sector by number of sector per cylinder. Okay. So surface number, it is equals to given sector number of sector by cylinder, it is total sector per track. Okay. Now let's see the next one, which is sector number S plus St into H plus St into Tc into C. So this S is nothing but number of sector. This is nothing but sector per track. This is nothing but surface number. And this is nothing but cylinder number. Alright. Now let's see IO models. Okay. First is programmed IO, where CPU time equals to speed of IO device. Second is interrupt driven IO, which is CPU time equals to IO interface time latency. Third is DMA. Okay. And in programmed IO and interrupt driven IO, we cannot access the memory directly. We need help of CPU. We need the help of CPU. Okay. So note this everyone. After that we will see data count. Okay, so let's see now data count. In data count, number of bits, words transfer, okay, from IO to memory units, the count value becomes 0. So when the complete data is reached, so from these many byte, it finally reaches to 0, and there it has to stop. Okay, so that it means X is preparation time, Y equals to transfer time, percent of time CPU is busy, which is x plus y into 100, and percent of time CPU is blocked, which is y x plus y into 100. Okay, so note down this everyone. After that we are going to see the short notes on maths. Okay, engineering mathematics. So we will be starting that. Okay, so let's start with engineering mathematics for complete 1 hour. So in engineering mathematics we have three subjects, three lessons we can say. The first one is linear algebra. Okay, second is probability, and third is calculus. All right. So see, probability comes for 5 marks. We have important topics like conditional probability, Bayes theorem, after that uniform binomial distribution, Gaussian distribution. In linear algebra we have basis, we have rank of matrix, system of equation. After that I am writing a maths. After that we have eigenvalues, eigenvector. In calculus we have limit, improper integrals, maximum, minimum, continuity, basic integration we have. Okay, so let's just start with the calculus first. So we will be starting with the calculus topic. So in calculus there are so many formulas which we are going to discuss. So first we have limit, limits, limits, which is limit. So for single variable we will see, so this is for single variable, limit x tends to 0 e of x minus 1 by x, which is limit x tends to 0 sine of x by x. Okay, and limit x tends to 0 tan of x by x, which is equals to limit x tends to 0 x by sine x, which is equals to limit x tends to 0 sine inverse of x by x, equals to limit x tends to 0 inverse of tan x by x, and all this is equals to 1. Okay, all this is equals to 1. So this please remember. Okay, after that let's see L'Hospital rule. So some says L'Hospital, some says as hospital, so anything you can say, no problem at all. So it's generally have 0 by 0, infinity by infinity, undefined format. Alright, so let's see now. Limit x tends to a f of x by g of x, which is limit x tends to 0 f, so this is derivation of x, g of x. Okay, after that we have to do this till we get finite values. Okay, this we have to do till we get finite values, and if it is in 0 by 0 or infinity by infinity form, then we have to apply L'Hospital rule. Okay, so keep remember this. Let's see the next now. So L equals to limit x tends to a okay, which is f of x by g of x. Now if we take log on both sides, so it will be log L, limit tends to x of a, this is g of x log f of x, okay. So what is continuity, everyone? Continuity means, see, existence, which is LHS equals to RHS equals to, the value is finite and it's equal, which is L equals to E x of a limit, which is g of x log n f of x. Alright, so continuous generally means LHS is limit x tends to 0 f of a minus h, and RHS equals to limit x tends to 0, so not x, because here we are using h, so it will be h tends to 0 like this, and this will be a plus h like this. So which is basically means LHS equals to RHS equals to f of a, and this we will say that it is continuous. Okay, now let's see condition continuity, conditions for continuity. Okay, conditions for continuity. So here it is LHS not equals to RHS. First, A is removable discontinuity, which means LHS equals to RHS not equals to f of a. Okay, after that B is jump discontinuity, which is LHS not equals to RHS. After that C is infinite discontinuity, which is LHS RHS is plus minus infinity, which is infinite. Alright, now let's see how to calculate maximum and minimum for one variable. Okay, so just note this, everyone. Now we will see condition for differentiability. LHS not equals to RHS, so LHS equals to limit of h tends to 0 f of a minus h minus f of a by minus h, and RHS is equals to h of 0 f of a plus h minus f of a by h. Let's see now maximum minimum. Maxima minima for one variable. One variable. So when interval not given or open interval so which is y equals to f of x. So step 1 is calculate dy by dx to get the stationary point. Okay. Step 2 is find d square y dx square. Okay. After that, step 3 is dx square y by dx square x equals to x0, and stationary point is x of 0. After that, if it is less than 0, then it is max. Okay. And if dx square y dx square, if this is greater than 0, then it is minimum. Okay. And if dx square y dx square is 0, then it is point of inflection. Okay. It is point of inflection. Note this, everyone. Noted, everyone. And do let me know if you have any doubt in this. Okay, I hope the points are clear, absolutely clear. Now let's see global maxima or absolute maximum minimum. Okay, so let's start with the global maxima minima. Or absolute max min. Okay, which is also called as closed interval. Alright, so the step 1 is f of x is 0. Okay, we have to do that to get the stationary point. Step 2 is put the value x of 0, okay, and for max global you have to find x of f of 0, x of f of 1, and so on till here to find the maximum value out of it, max, and minimum global which is f of x of 0, f of x of 1, okay, minimum value to get. After that we will see improper integrals. So improper integral A is range of interval is infinite, okay, which is A like this, f of x d of x, which is limit t tends to infinity a of t, which is f of x d of x, which is finite convergent bounded, okay, and some infinite divergent unbounded. So minus infinity to a, which is f of x d of x, which is limit t tends to infinity, which is t of a f of x d of x, which is finite convergent bounded, infinite divergent unbounded. All right, So b is function is not defined. If x equals to a not defined, then L of t h is 0, f of x d of x, this is RHS if not defined. Okay, and after that limit h tends to 0, a b minus h LHS. Okay, now let's see some properties. So basic integral a to b f of x d of x, which is a b f of a plus b minus x d of x, minus a to a f of x d of x equals to 2, 0 to a f of x d of x. Okay, so calculus is completed. After that we will see probability and statistic. Probability and statistics. A is P of E, which is events upon sample space. Second is probability of A by B. Which is probability of A intersection B by probability of B, which is conditional probability. Okay, third is for dependent events, which is without replacement. So probability of A of probability of B, which is probability of A And what is independent event? Probability of A intersection B by probability of A probability of B. Alright. Now fifth is probability of only A, which is probability of A intersection B complement, which is probability of A into probability of B, and this we can write when we consider them as independent events. Okay, which also we can write it as probability of A 1 minus probability of B. Sixth is P only B, probability of B intersection A complement. Okay. Seventh is probability of A intersection B, which is upon sample space. Eighth is probability of A union B is probability of A plus probability of B minus probability of A intersection B. Any doubt in this? Okay, so let's see now the ninth one. Probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Okay, and do have the knowledge about Bayes theorem and Bayes theorem and total probability. Okay, have that knowledge as well. Let's see cumulative distribution. Okay. After that, PDF is f of x of this, and this is the region. Okay. And this is CDF. Okay. So the relation between CDF and PDF is note this. So do let me know if you have any doubt in this. Okay, now let's see expected values. This is for discrete. So this is for continuous. Okay, and note this. Okay. We will also see variance. So this is variance. Okay. And standard derivation is variance. Okay, any doubt in this? So for continuous, it is a by b x square f of x d of x. This is for continuous. And for discrete, e of x square summation of I1 to n x square pi, and variance of minus x equals to minus 1 of square var x, and var of a of x plus by, so which is a square var of x plus b square var of y. Okay, then let's see one important table. So binomial distribution. Okay, binomial, Poisson, Gaussian, and uniform. So the first, this is discrete. This is discrete. This is continuous. Okay, now here is probability of x equals to r, which is n c r p r q n minus r. Here p x equals to r, which is, so this is mean, okay, which is e minus r factorial. After that, Gaussian is 1 upon mu under root 2 pi e minus x minus mu square 2 square, and this continuous is 1 minus b minus a f of x. And here mean equals to x into p, variance equals to npq, and standard deviation is equals to under root of npq. Okay, here mean is lambda, variance is lambda, and standard derivation is under root lambda. Here mean is mu, SD is like this, and variance is, okay. After that, here is e of x a plus b by 2. Here is variance of x is b minus a square by 12, and here standard deviation is v of x. So you all can note this. After that we will see Gaussian normal distribution also. Okay, so let's see now Gaussian normal distribution, because Gaussian we have already discussed. So this is standard deviation, this is mean. So generator diagram is like this. Okay. Like this. So probability of -1 smaller than z1, this is 0.6834. Probability of probability of 0 smaller than z1, this is 0.3417. Probability of -2 z2, this is 0.2545. Probability of 0 z2, which is equals to 0.4774. Probability of -3 z of 3, so this is 0. Okay, so till here there is no need, you all just can remember till here. Okay. After this we will see linear algebra. Okay, so let's discuss First is rank of matrix is equals to number of linearly independent row or column. Second is number of non-zero rows is non-square matrix. So this we can do by using elimination technique. Okay, Ax equals to 0, this is homogeneous. As equals to b, this is non-homogeneous. Alright, note this everyone. So let A is not equals to 0 and it is 3 cross 3 matrix. So if it is 3 cross 3 matrix and determinant is not equals to 0, so rank of the matrix is equals to 3. But if let A is coming 0, then rank will either be 2 or it will be either be 1. So when it will be 2, when all sub-minors are not 0, if you find that, then the rank is 2. And here if it is 1, when all sub-minors are 0. Okay. So let's see the next one. X equals to 0. So this we know that this is homogeneous. This will be unique, or this can be infinite. So determinant of A is not equals to 0. Rank of matrix is equals to number of variables. So it is unique, it is trivial solution. Okay. Now when the case will be infinite? When determinant of A is 0, which is non-trivial solution, and rank of matrix is less than number of variables, then it is said to be infinite solutions. Okay, infinite solution. And this is for homogeneous, and in homogeneous no solution does not exist. In homogeneous either it will be unique or it will be infinite. Any doubt till now? Just answer. Okay, so let's see now, when it is non-homogeneous, then how it will be, how the cases will be. Let's see, a of x is b. Now this is completely homogeneous, no sorry, non-homogeneous. So now when it will be consistent, okay, we are discussing for the consistent case. So consistent case first comes when if rank of a is equals to rank of c is equals to number of variables. Now what is rank of a and c? So this is a C matrix which is a and augmented with b. Okay, so rank of c is a augmented with b. So it's basically like this. Here we have some variables and here we have some variables, like this augmented matrix. Okay, after that, second is rank of a is equals to rank of c but is smaller than x. So here it will have infinite solution. Okay, and when it will be inconsistent, third case, rank of a is not equals to rank of c, so no solution will be there. No solution will be there. So please note down this, everyone. Okay, so now let's see eigen values, eigen vectors. So a of x is lambda x, a is matrix which is square, this is eigenvector, vector, x is eigenvector, this is eigen value, a is x into x equals to 0. Okay, so here eigenvalue can form characteristics equation. Okay, so there are C. If a is lambda 1 lambda, so this is the eigenvalue, so a to the power m will be lambda of power 1 lambda of power 2. Okay, if a has eigenvalue 1 and 2, and if it is multiplied with k, so it will be k lambda 1 k lambda 2. If a is lambda 1 lambda 2, and if this is inverse, then it will be 1 lambda 1 1 upon lambda 2. If a is lambda 1 lambda 2, so adjacent of a is equals to a upon lambda 1, adjacent of a is equals to lambda 2. Okay, if one eigenvalue is at least 0, then determinant of A is 0. Alright, and characteristic equation of A, B, E, D, characteristic equation of this is lambda square minus trace lambda plus determinant of A is equals to 0. So this is for 2 cross 2, and for 3 cross 3 it will be lambda cube minus trace lambda square plus A11 plus A22 plus A33 lambda minus determinant of A equals to 0. Okay, so now the only thing left is properties of eigenvector. So please note down this. After that we will understand what are the properties of eigenvector, and there we will be completing with the complete COA and maths. And the last subject left is DMS, that we will cover in complete tomorrow's class. Okay everyone, so we will now discuss properties of eigenvector. If it is a to the power m, still eigenvector will be same. If it is a inverse, then eigenvector will be same. If it is a transpose, so same it will does not. Okay, so this will not be same, but if it is a and a to the power n plus a0 minus 1, so this will be same. Okay, so you can all note this, and do let me know if you have any doubt regarding today's lecture. Okay, so see you all in the next class. Thank you so much, everyone.